We're going to continue where we left off yesterday with our Desmos activity. So our Desmos exercise, you either can go through Canvas, click on it, or you can go to student.desmos.com, and the last 6 characters are your classroom code. So the last 6 characters are your classroom code. If you do not have your laptop yet, I do have desktops that are available. And it can be done on your phone. It just gets really frustrating if you do it on your phone. So if you haven't gotten your school laptop yet, or your personal laptop, I think you can log into a desktop. But what you're doing here is you're doing a card sort and explaining the card sort. And we're going to do it for about 10 minutes. Yeah, you go to student.desmos.com. Yeah, on your phone, you got to turn it horizontal. Since I can't give you all the actual, the normal old school method of giving you cards and you sorting them and discussing with your peers, the joys of that has been taken from us. They're almost the same.
Are they in a classroom?
They are in Canvas. You can go to Canvas, or you can just type students.desmos.com and put in the last six characters. Whichever way you want to go. You need the charge, right? It's right there. You want to use desktop or oh, you already did. And we're just about 10 minutes. All right, at home peeps. How can we help you? Camera, I forgot how to make this thing work. That we can show my face. I'm just going to be sideways. So guys, my camera is sideways. So you just put SUKW9U. So we have a Canvas discussion post. It's so that us in class can collaborate with the people online, so that it's a community of learning. Does that make sense? And so when that happens, I'll put a post out. So for example, we have a discussion post over function versus not a function. So after doing your Desmos, after taking the notes from yesterday, can you give me a visual or verbal example of a function and not a function? So if you do not have access to, well, we're not using it right now. And so what that looks like, we're going to go to Canvas and we're going to look at the discussion board. So this is me looking at it from a student perspective. I'm going to look at my function versus not a function. And here it tells me to create a post giving a visual or a verbal example of a function and not a function. So I did an example here. When it says verbal, this is a verbal example. So verbal just means you're typing in function. I work and make $8 an hour and get a weekly bonus, right? Not a function. If I was to compare boys and girls' heights in my class, okay, that's just your verbal. Those are your options. Other option is to do a pictorial representation, and pictures are really easy. You go to Google, you find one you like, you right-click copy, right-click paste, and it's literally that as easy as it gets when you're posting a picture in a discussion board. So to model that really quick, so reply. I'm going to go here and I'm going to look up function versus not a function. I may just even be lazy and find one big picture. I'm going to right click on it, hit copy image, go back to my post, and I literally right click and paste it. And it will put in an image for you right there, okay? The only time it doesn't work is if what you're copying and pasting is not a JPEG or a PNG file, okay? That's the only time it will not work, if it's not a JPEG or a PNG file. And then you've now given me an example, you now have an understanding, and you're gonna post a reply and you're done. Easy enough? Any questions about it? So again, you have the choice to do the verbal, you have a choice to do pictorial or a combination of the two. Cool? All right. So I'll leave y'all to do that. We should have time to do it quick. Huh? On Canvas? Mm-hmm. Yeah. You're done. There's no more next. When I see their responses and you type yours in, and then I should. Yeah, it should. All right. So any questions about posting in the discussion board, or do you feel confident and comfortable being able to do that? Good? All right. Posting it from a phone. So if you post in the discussion board from a phone, to add a picture, you just got to have the picture saved to your phone and then you just upload it. Okay. All right. So that's that. So Canvas discussion post, function versus not a function. You create a post giving a visual or verbal example of a function and not a function. And that's what I'm going to have you. You'll do. If we have time left in the class, but we're going to get through the notes in class face to face. That's why I wanted you in class to make a note, create an idea, decide what you're going to do, and go from there. Cool? Oh, we're about to just start regular notes. You know. That's what it says in your notes, just to make a note of it, so you can go back and do the discussion post. All right. So notes notebook. Date and title when you add something. This is a good practice for organizing. The more organized you are, the easier it will be for you to study for the test. Notes will be available on Canvas, so do not feel obligated to rush and write everything down, okay? Write down what is new information to you. If all you need is a picture, draw the picture, okay? Do not try to exactly what's on the board, because I'm telling you, when you go to college and those professors, if they put the notes on Blackboard or Canvas or Brightspace, they're expecting you to know that that's where you can access them. So their pacing of the class isn't like slow enough for you to write everything down. So our notes today are 1-1 key function vocabulary. Some of these terms should be reviewed. Some may seem new. I will tell you the video that I made and posted on Canvas is not the world's greatest video. It was just to make sure that they had notes in case they wanted to work ahead. So we have 1-1 key function vocabulary. And our first vocabulary were Xintercepts. So key things about Xintercepts: the point at which a line/function crosses the horizontal x-axis. The coordinate points are x, 0. A function can have more than one x-intercept or no x-intercept, okay? So on this graph, you can clearly see where we have our x-intercept. Any questions, comments, or concerns about x-intercept? Pretty straightforward. Remember that guy? And again, you're writing down what you need, not just to write to write. All right, so I need just little signals. If you need 1, let me know. 2. Okay. like, yeah, a little more time. A little bit more than a little bit more time. Okay? My plan was to spend like a minute on each slide, so. Or less. Oh. Were you still? Were you still? All right, y-intercept. So y-intercept, the point at which the line crosses the vertical y-axis, the coordinate pair is written as 0, y value. And if a relation has more than one y-intercept, it is not a function. Okay? If a relation has more than one y-intercept, it is not a function. All right, so we're using the same image before. But this time we're going to highlight where the y-intercept is. And there's our y-intercept. Crossing the y-axis, notice how my x value equals 0. So again, if there's more than one y-intercept, it's not a function. All right, a discrete function, which was talked about yesterday, is a function in which the domain and range of each set of values rather than on an interval. So on a graph, the points are not connected. The other way to represent a discrete function is as a ordered pair set. So if I have, where are my points? 2, 1, I have 1, 3, I have 3, -1, 4, 2, 5, 0, and 6, 6. So I can represent it as a set of ordered pairs. I can also represent it as a mapping. And so in a mapping, I have my x's in one oval. That's 1, 2, 3, 4, 5, 6. I have my y's in the other oval. And my y values are -1, 0, 1, 2, 3, and 6. So 1 goes to 3, 2 goes to 1, 3 goes to -1, 4 goes to 2, 5 goes to 0, and 6 goes to 6. Okay, so these are all three ways of representing the discrete data. I can also take the mapping and turn it into a table. Questions about discrete functions and representing them? Easy breezy. All right, next, continuous. So continuous function means a graph has no jumps, no breaks, no gaps. The gap can be traced without lifting your finger. So when you look here, this is my continuous graph. Because here's my finger, and I can literally trace it. So that's what makes it continuous. Questions about continuous function? Layla, it's going to be posted on your canvas. You have to take pictures.
It's already on canvas. Oh, no, I had to.
Oh, it's on Canvas. It'll be on Canvas.
Yeah.
Questions about continuous? Easy enough? Fingers? That's how you check it. If there is a gap, jumps, breaks, or holes, then you know it's not continuous. Next, y-axis reflection / symmetry. A graph is symmetric with the y-axis if the y-axis divides the graph into two equal parts. The values a, b, and negative ab exist for all values of the domain. So what that means, so see here how we have this graph. The y-axis is literally my axis of symmetry. I now have two parts. If you look here, I have a value here at 2, 0, and I have a value here at negative 2, 0. I tried to put a comma. That didn't look very well. Okay, so I have the x values are opposite, the b values are the same. So that's y-axis reflection symmetry. And that pattern will continue as you keep going up. Okay, once we get to our polynomial section, we'll later learn that this defines what's called even functions. Questions with y-axis symmetry? Comments about y-axis symmetry? Easy enough? Do you feel comfortable identifying whether a graph has y-axis symmetry? That's the question. Cool. All right. Next, my friends, we have origin / rotation symmetry. A graph has origin symmetry if it goes through the origin, and if you reflect it across the x-axis and then the y-axis, the graph is unchanged. So what this means that you're doing is if you turn the graph upside down, if you turn the graph upside down, it looks the same right side up. And the values of your original x and y, well, your positives and its negatives they're part of the domain.
What's the name of that on you?
On what, sweetie?
On Canvas? Like the slide?
1-1 vocabulary. I haven't put it yet. It's the video. I put the video of it, but I haven't put the text yet. But I will. All right, so see this graph? If I was to rotate it 180 degrees, notice, is it the same shape? Did we see that? We can do it again. So here's the graph. I rotate it. Exact same shape. The function is still increasing from left to right, still going through the origin. That's what the origin symmetry means. Hence why it's called rotational symmetry. If I can rotate it and it's unchanged, all right? Questions about origin rotation symmetry? Cool. Next, we have x-axis symmetry. If a graph has x-axis symmetry, it is not a function. And that's because the x divides the graph into two equal parts. And the values of AB and A negative B exist for the domain. And can you have repeating x values with a function? No, you can't. So there's the problem right there. So then when I graph it, it's going to fail what test? What's that test called that it fails? What's the test called? It's called the vertical line test. It fails it multiple times, right? And so if it fails the vertical line test, then it is not a function. So if a relation has it's there now, if you refresh. All right. Minimum value. So the minimum value of a function is the least y value of the function. It is the y coordinate of the lowest point on the graph. Okay, notice it's the y coordinate. If on an interval from A to B, the minimum can be calculated, but visually, you're looking for the lowest y value. So when I'm looking here, my minimum value is at where it's at. Where is at x equals -3/2. What it is, that's how you spell what. What it is y equals -9/4. So where it's at is the x value. What it is the y value.
It doesn't have any words.
What?
It doesn't have any words.
Huh?
It doesn't have any words. It's a verbal vision.
That's not it. Well, let's see the side. That's from what. Are you sure? All right, minimum value, done. What's next? Maximum value. So you want to take a stab at what the maximum value is? The highest, the greatest. It's the greatest y value. It is the y coordinate of the highest point on the graph. On the interval, it can be calculated. It's your maximum value. And again, where is asking for the x? What is asking for the y? Remember, x marks the spot. So where are you going? To the spot. Huh? What time is it? We have less than a minute. Well, we have a minute and some change. I know. Good learning, man. Okay, just really quick. Your last one is asymptote, but that's part of your homework. I just want to make sure you all know where your homework is. Your homework isn't due until midnight on Saturday. But your homework, you're going to make your own Google presentation of the vocabulary. So vocabulary assignment. It's similar, yeah. But make sure. So click the file, make an entire presentation. Make a copy, okay? If someone keeps asking me for permissions, it literally tells you make a copy. You will use your notes over the lesson to create your own verbal example and use the internet to find an accurate visual example, okay? And it goes through all of the words for you to do. And then when you're done, you will submit the assignment, okay? You will submit the assignment by going to your Google Drive and then just selecting the document, okay? Any questions about your homework? If you are, did our time change? I think this is the period that. No, this is the between period. All right. All right, y'all. Thank you for a great class day.